everybody for making it. Today I'm going to try and introduce you to some ideas that are not very prevalent throughout any university worldwide. But, not prevalent, but it doesn't mean that they don't exist. This is perhaps the most quickly increasing approach to cognitive psychology, to the study of the mind, that exists in the world today. But a lot of people haven't heard of it, ecological psychology. What's it about? So I'm going to try and give you a philosophical perspective on that as best I can, but I'm not trained in philosophy, I'm trained in psychology. So please leave your hard questions until the end. I have quite a few slides to go through, in fact, so please, if you resist just clarifying questions rather than philosophical debates, otherwise I'll not get through it. I've got much more than 10 slides. Okay, we'll get back to that interesting figure in a moment. But for some of you already, you may be noticing that not only is this a moving image, and what you're seeing is, in some sense, a moving object, but you might be noticing something else about it. Would somebody like to offer what they see?
It's spinning.
It's spinning.
She changes direction.
And does it change direction for everybody?
Yeah.
And if it's not changing direction, read the title, or just put your eyes somewhere else. And then your experience will change. So this is telling us that the way we experience the world is not always so stable. This is a bistable image, as they're known in the trade. It can rotate one way or another, depending upon more than just the visual stimulation, if you like to call it. There's something else involved. You with your brain and your body. Okay. So, about 500 years ago was René Descartes, who changed everything in the philosophy of science and the philosophy of perception. He's well known for his I think, therefore I am, cogito ergo sum. And the problem Descartes had was reconciling two different states of the world, two different substances, mind and matter. Mind-body dualism, you will have all heard of, is due to two fundamentally different substances that he conceived of, material matter and what he called the soul, which is now the technical term for the soul has transformed into the mind. But the Cartesian dualism is mind-body dualism, separation in substances. And philosophers ever since then have tried to get rid of this darn dualism somehow. But basically today, this is the everyday man in the street perspective on what we've inherited. Perception follows sensations. Sensations of the skin, sensations of the eye. The brain organizes the signals and translates them somehow into something meaningful. So the meaning is created from meaningless signals. We become aware of the meaning somehow, and that produces or is continuous with, or at the same time exists with consciousness, whatever that is. So that's just a very simplistic, completely incorrect at a technical level characterization of what we've inherited from 500-year-old debate. The ghost in the machine, you might have heard of. This is a René Magritte interpretation of this perennial problem. So the brain organizes the signals is the standard assumption, and we all know about neurons, and this is in fact Descartes' kind of conception of signals coming into the brain, where they're somehow involved in activating the pineal gland, which was his seat of the soul. And for him, the soul had religious connotations. There was a very deep and definite religious background to the Cartesian worldview, that mental states were really states having to do with a religious perspective in the universe. For example, animals couldn't have a mind. They only had sensations, just the mechanical, material, electrical signals. So now we've got fancy schmancy views of how vision works. You know, we're all turning into androids, it seems, and we've got the conception now, the concepts, or the technical version of the story is that light comes in, creates a retinal image, goes to the back of the brain, gets interpreted. Okay, so you've got this little retinal image conception and assumption. This is quite a ridiculous assumption that you hear trotted out continuously in the media, in the standard publications, even at the scientific level, that the basis for perception is an inverted retinal image. Do we ever see a retinal image? No. We see the world. In fact, the idea that we see the world is known as realism. Descartes was a realist also, but only at the level of his soul. At level one soul does one see a real world. A world was assumed for Descartes. And today also people assume there's a real world, but all that we have contact with is some sort of sensation such as an image. We never see an image. The only way you see an image is if you take a dead ox's eye, hold it up to the light, put it in the middle of a curtain so that it blocks out the light, and then tear off the back of the eye, the sclera, and you can see an image. So what? Does that mean that the basis for vision, for perception, is an image? You don't even need an eye to see. You know, the eye evolved. Okay? I'm going to present to you an evolutionary story. And the eye evolved from other ways of getting access to the environment via electromagnetic energy. And a compound eye consists of thousands of little reticuli, I think they're called retinula. Okay, they've even got a small kind of a lens in each one. But if you were to look at the back of that, you'd see 1,000 images. A mosquito brain, a Drosophila, a fruit fly, does not have to interpret 1,000 images so that it doesn't get confused. It's a nonsense. The image is not necessary, as I'll try to admit you. So the story goes, of course, you know, these fancy schmancy signals going to the back of the head, and that's where vision occurs to a large extent, to the extent that huge experiments, an experimental program going back to the 50s has looked at the sensitivity of cells here, which are sensitive to the direction of spots moving from left to right, or moving diagonal even. So the notion is that we build up, the brain builds up a representation, a picture in the head. Okay, a standard, assumed way of doing. Every undergraduate gets this story presented to them. So going back to the assumed theory, we've got a sensation perception. Every textbook the undergraduate gets now is called sensation perception. So that's what they start with, sensation and perception as a separation. Sensation is considered passive, physical, meaningless entities at the level of the body, whereas perception is something that comes afterwards. It's active in the sense that it's actively organizing and creating sense out of meaningless physical inputs. It's intelligent and so on. And that's the mind, Descartes' soul. Mind is the technical term for the soul. Now, slightly different interpretations today, given that I give you that. So knowledge is then needed to interpret the meaningless sensations and turns them into meaningful perceptions. The current way of thinking about this problem, this is the deepest problem facing philosophy and psychology today, is the mind-body problem. They try to avoid naive realism. What is naive realism, by the way? It's that when I open my eyes, I don't see retinal images, I don't see sensations, I don't feel them, I don't know about them, I see the world. All of you get around the world by saying, look at that chair, look at that glass, and people know what you're talking about. Don't say, well, let's consider that I'm seeing a chair given the retinal sensations, blah, blah, blah. Naive realism is what we are used to. But there has been a huge prejudice against naive realism for some very good reasons, actually. It isn't quite right. And there are two main arguments against it. One is the argument for science, which says, well, we're getting to know more and more about the way matter works. Water is basically just H2O, solidity is just certain molecules in certain organizations, so we can reduce things and find out the reality of the world, quantum mechanics level. We think that's the best. So it is an argument that is trotted out for this. But there's a more specifically psychological set of arguments, which is the argument from illusion. And you can't trust the senses because of illusions. So you're all familiar with illusions, the Muller-Lyer illusion. You know, they look like different lengths of straight bits. The straight lines look different, but in fact they're the same length. So the argument from illusion says, well, given that the sensations are the same at that level, then why do you see something different? You can't trust sensation. Naive realism can't be right. You can't see the world if it's just based upon sensations giving you the world. You can't trust your sensation to know the world. Is that a straight line or not? Well, in fact, it is a straight line, but it doesn't look straight. A famous hearing grid illusion of bent lines. These all involve context, by the way, right? Context, context, context. Nobody emphasizes the context, but they should. And these are bistable illusions. This is where you have the same input, as it were, same marks on the page, but you see different things. Okay, so the Necker cube famously switches from a left-facing to a downward, from a left upward to a downward right-facing cube. As you stare at it, it should switch. Does it not switch for anyone? If it doesn't switch, look away a little bit. Your brain is an inherently unstable device. Inherently unstable, but it can be reasonably stable given sufficient information, as we'll see. So this is the argument from illusion, that you can't trust your senses given these demonstrations. Okay, you've got spots in front of your eyes, look, fixate this black dot, and you get black dots at the intersections. This can be explained by some fancy models in neuroscience, looking at the horizontal cells in the retina and all that. And they've come up with some stories about this. But regardless, your experience is different from what is given here. More illusions are always fun to show. So can you see the old woman versus the young woman? If you provide more information, it makes it easier to see the young woman and the old woman. So I keep emphasizing this. If you give more information, the illusions become less illusory. Okay, and the problem with aging. Right, can you all see the old woman there? Can you see anything else? If I give you more information, then you start seeing what else is there. They always choose young ladies or old ladies for these experiments, I'm not sure why. And then this is the famous one that became viral in 2009, 2010, created by a German fellow, the spinning ballet dancer. You can look this up even on Wikipedia, read all about it. And interestingly enough, if you look to the side of this, it will switch. As you keep looking at it, it may not switch so easily. Your brain becomes reasonably stable in a sense, to use that technical jargon. Brain, stable, etc. And if you want to see a little bit more of her body, you can go inside, of course. But you get the same problem of a bistable image. It will switch. If this one doesn't switch, look at her and it will switch. Okay, so they're good. They're fun and games. But the philosophical point here is that the argument from illusion tries to tell you that you can't trust your senses. That you need some sort of mental interpretation or knowledge to make sense of the input. For example, these are the same levels of grey. But context changes everything. The information is not just this patch of grey, but the surrounds as well. So these are actually the same level of grey. And if you don't believe me, hold up, do that, and look at that piece versus that piece, and you can see that they are. A and B are the same level of grey. You don't believe me? A and B are the same colour. A and B are the same colour. I'll prove it to you. Okay? They're the same colour. But they don't look the same colour, but they are. They're the same level of grey. You've got a shadow cast, you've got a whole bunch of context going on, so on. Illusions are only illusory because they screw around with the display. This is not what you see in the real world. Those duck rabbits and so on are not what you see. They're tricks created by very clever scientists, and sometimes called psychologists. Let's say you imagine you're seeing this scene. Are these people the same size? Well, if you saw that scene, you wouldn't say, well, she's a giant, he's a little guy. You say, yeah, they're the same size. It's called size constancy. But you've got different sized retinal images. This is the classic argument from illusion. Every philosopher and every psychologist knows this backwards. My apologies to the experts. But I do want to make this point and emphasize it. So different sensations are caused by the same sized object at different distances. Same sized person, just at different distances. So given that you can have ambiguous retinal images, so the argument goes, then how can you trust what's out there? The argument from illusion, naive realism can't be right. Well, along comes a guy called Gibson, James Gibson. Wanted to do experimental philosophy, was his goal in Princeton in the 30s when he started his PhD. And set out to do experimental philosophy in a sense. His first book in 1950 gave rise to the rest of perceptual psychology of the last 50 years, basically. This is a very talented, ingenious scientist. So he came up with things like the texture gradient concept, the notion that distance is not, as was debated by Bishop Berkeley and the like, a line endwise to the eye. How do you see distance? How do you see a line endwise to the eye? How can you see how far away something is if the line is endwise to the eye, right? You know, how do you see a ruler to measure a distance if it's like that? You know, there's no length there. He gives that nonsense. He said that's a nonsense. He pointed out that there is always a context in the real ecological world. There's a landscape with texture on it, the texture gradient concept. So we tried to develop a ground theory of size perception, not an air theory. So here's out of Gibson's 1950 book, a demonstration of how the same retinal image, but your perception is of different size because of the relation to the context, to the texture gradient. So by starting to realize that simple drawings and illusory diagrams are too impoverished, they don't have sufficient stuff in them to make you aware of the real situation. Even this is highly schematized and leaving out details. But the details don't matter. What's important are things like the gradient that is related to distance and the objects in the cluttered environment that occlude, that cover that background. That's sufficient. That's sufficient to see distance. Another discovery by Gibson was this notion that you can see your own size in the environment by virtue of the optics of the horizon, or basically the vanishing point. If you don't see it, if you're not living at the sea, you won't see a horizon. But you've got still the convergence, optical convergence known as vanishing point. And the horizon intersects objects at the viewer's own eye height. Yes, it does. So if you are at the beach and there's the horizon and there's a doorway, your eye height effectively always intersects the horizon because the horizon is at optical infinity. So lines from optical infinity are parallel, are coming parallel, photons if you like, are coming parallel from optical infinity to the ground where you are. And so the optics will always intersect objects at your eye height. Okay, so here's two different people. You're looking at the scene, and you can see that they're the same size because the horizon, apparently you're a little guy here, you're a little 10-year-old, little 6-year-old boy, right? Because your eye height is only as halfway up your father's body, as it were. Okay? But that's how it works. And interestingly, you're not just seeing the size of objects, you're seeing them relative to yourself. This is very important. So there's an element of subjectivity coming into this analysis. There's an element of the self, of self-awareness, coming in to the information that is available to any organism. To an elephant, any organism with some height is my example. An elephant, giraffe, a dog, is going to have this information available in the optics. Okay, so here's a few technical pieces of jargon with regard to what we're talking about. In the last 100 years, there have been several attempts to banish this mind-body dualism. Starting off 100 years or more ago with phenomenology. Now, this is very important because this tried to take very seriously our everyday experience, the naive realist perspective of experience, without trying to reduce it down to particles, without trying to do what the Greeks and Democritus did, which was look at the elements. Rather, taking experience for what it is, and trying to understand the structure of that experience. So the French like to do this, the likes of Merleau-Ponty, and so on. The French are very good at long, descriptive efforts to describe reality. And phenomenology wasn't just French, but the likes of William James, the American tradition in psychology evolved out of that and gave rise in the start of the 1900s in the States, in the United States, to a group called the New Realists. And the New Realists took very seriously phenomenology. William James is, a great psychologist. And phenomenology has got a lot going for it. Along comes then behaviorism and rat experiments and all that. And they try to get rid of mind-body dualism by just saying there's no mental states. Let's just look at the output behavior caused by the stimulus, by stimulus-output relation. You can train dogs through behaviorist techniques. Works great. You can train people even through behaviorist techniques. Classrooms every day. Stop looking at the clock. They're conditioned to look at the clock at 5:02, So this actually works for learning theory and so on. But the theory of behaviorism ignored our everyday conscious states, or the existence. I mean, I'm not denying mental states. I'm not denying that you right now have a belief that you can walk to that door and go and see your grandmother for a cup of tea, that you're having that thought. I'm not denying any of that. But some of these approaches do deny the existence of mental states. Now we get into some technical things like type identity, reductionist approaches that try and reduce mental states to matter. So this says that any type of mental state just is a specific type of brain state, a specific type. But the problem with that, for example, pain. For example, pain. I have a pain now. That's just some activation in my reticular formation or in the C fibers, as John Searle likes to call them, the C fibers coming up from the pain receptors to the spinal cord. It's nothing but a specific kind of material, physical state of the neurons. But the trouble with that is that, let's say, my dear wife and colleague in the back row has a thought now about where we're going to eat dinner, and I have the same thought about the same restaurant. But we have different brains, do we not? And so the problem with that is that we cannot both then have the same mental state if we've got different brain states. Right? So then along comes token reductionism, which says that different brain states can be the same mental state in virtue of their function. The function of my brain state is to be about the restaurant I'm going to. Function was then emphasized, which leads to functionalism, the functionalist approach of the starting off in the 40s, 50s. Mental states just are the causal relations of inputs, brain states, and outputs. Provided that there's the right set of causality between inputs, brain states, whatever brain states are and outputs, that functional, see, there's a sort of goal-oriented perspective here. Teleology, and directedness, the function of things. Provided the functional relations are right, that's what matters. And then along in the 50s comes Alan Turing, the great Alan Turing, who invented the theories behind computation, the Turing machine. Basically, any material system, a set of old beer cans and string, as Searle calls it, can be made to be a computer provided it has the right functional relations. So all computers are basically Turing machines. So this is now an existence proof of functionalism. Computer functionalism is known as. Turing reductionists. We can have the same mental states, Mira and I, because we've got the same program running. Brains are like mental states are like software, and hardware is like brains. So the analogy, it's not just an analogy there, well, it is an analogy, and a strong analogy used by then cognitive scientists. And this is where we're at today. This is 99.9% of cognitive science is computer functionalism. Not ecological psychology, but computer functionalism. We all learned about this in grad school. Some of us lived it when we started PhDs in artificial intelligence, like I did. Well, I quit a PhD in artificial intelligence to do what I'm talking to you about today. Because it's nonsense. Because quite rightfully, there's problems with that. What are the problems? Intentionality and mental content, or the aboutness of mental states. I'm having a thought now about the restaurant. The philosophers technically call this the intentionality of our mental states, the aboutness. And the famous philosopher I return to is John Searle, talking about intentionality. And he's come up with a perspective called biological naturalism, which is that consciousness is just a higher level feature. It's just like reducing H2O to water, but instead now there's a feature of matter which is consciousness. And he tries to say, well, this is a perfectly scientific perspective, but it doesn't really, I'll say more about this, but it doesn't really do it. It doesn't explain the aboutness. He thinks there's something special about our brains, that they can have conscious states, but, and so could another animal, or even beer cans and string, if it was special enough, but it doesn't explain the intentionality, although he thinks it does. And today, very popular in the last 10, 15 years, is an approach that's become quite prevalent, trying to make sense of this, called externalism, or externalist approaches, rather than our mental lives being inside us and the meaningful content of our brain, of our mental states being inside, internal. It's trying to take seriously the notion that content involves the environment in some way. But if you're a philosopher, you know, the arguments behind this are very fine-grained and very detailed. And we don't have time today to go into the intricacies of it. But it's interesting. The externalist approach is interesting and worthy of your attention. So I'm going to address the problems of attentionality by introducing you to direct perception. God, we started 10, 15 minutes late, and we're not going to get very far at this rate. Well, we did start 15 minutes late.
It's all an illusion.
Direct perception, I'm going to use to introduce an alternative way to think about intentionality and affordances. Complex systems, well, we'll talk about that if we get time. Today, people try to talk about embodied and situated cognition, that my thoughts are situated in a context. This is the right way to think. But I want to tell you that a guy called Gibson was thinking about this in 1966. He wrote 3 books, 1979 when he died, 1966, and I don't have 1950, which he wrote after his time in the United States Air Force, where he was the Captain James Gibson. He tested the pilots. He helped pilots learn to distinguish one aircraft from another. He was the chief psychologist. But 66 book, the sense is considered as perceptual systems. Not sensation and perception. The sense is considered as perceptual systems. The senses, 5 senses, whatever you want to say, are perceptual systems. There's no distinction between sense data, sensory material inputs, and intelligent perception and awareness and meaning and all that nice stuff, all that sexy stuff like meaning. There's no distinction there. The sense is considered as perceptual systems. And that's where we started introducing affordances. And embodiment. The notion that it's not just the brain, it's not just the eyes, it's the eyes and the brain on a head, on a neck, on a body, walking through the world. This was always Gibson's emphasis. And people are starting to catch up. Slowly. But it's been around since the 60s. And then we've got the problem. The problem, by the way, for the people who have come in just now, we're trying to get rid of the mind-body dualism problem. And there's still problems with computer approaches, with the computer functionalist Turing reductionist approach. Self-awareness. Computers aren't self-aware. Don't tell me they are. I don't care how sophisticated a robot you show me. I'll get time, I'll play you some incredible footage of the recent robots they have now. But they're not self-aware. But we'll look at the experiments on that having to do with ego motion, the motion of the self, the self-awareness through motion. Some are calling this the ecological self. And the third thing I'll look at is this big problem of the subjectivity of experience. Philosophers make a big deal out of, okay, so you've got all these neurons and so on, and brain states and whatever, but how do you explain when I open my eyes, I see red, right? Or whatever, or I feel this feeling. The feeling of experience. They seem to get hung up on the notion, they call it qualia, right? The problem of qualia, problem of first-person consciousness, first-person feel of things. It's one thing to be able to pick up a book. A robot could do that. But does the robot have the same conscious feeling of doing it as I do? Or seeing red, or seeing colors is often the example given. So, trendy guy in this area, David Chalmers, has become famous by talking about the hard problem, which is explaining this feeling of experience, this subjective feeling. He calls it the hard problem, which is ridiculous because for him the easy problem is all of the neurophysiology and all of the psychology. That's just nuts and bolts, you know. You'll eventually figure out how you catch a fly ball in cricket or in baseball, the term comes from, or how a wicketkeeper catches the ball in cricket at such a fast speed. That's all just nuts and bolts. You know, it's incredibly pejorative of him to call all that the easy problem, whereas this is the hard problem, which he devotes his time to pondering and because. So, well, we'll have something to say about that when we think about information as specifying resources in the world, basically food. So, my goodness, now my talk starts. Let's give you an example. How do you see the world? How do you see how high a stair could be? Right? We have to climb all the time. Even the climbing goats of Namibia have this problem. This is real. This is blooming real. You can check it out in Google. These goats climb trees for fun. So let's look at the problem of how do we know the properties of the world. Okay, so this experiment was done back in the mid-80s. How do we see step height? Well, we can measure the maximum step height that you can climb up. This is Bill Warren's famous experiments on stair climbing that some of you have heard of. And we can biomechanically show that around 0.88 for a physically normal average person, regardless of size, they can maximally climb about 9/10, right? 9/10 of the leg length. So for me, my leg length is 85, and my max is 75. So it's a bit higher than that, but it's not that. I can't climb that. And interestingly, you can see that I can see that. I can see that I can't climb that. How did I know that? Never tried it before, actually. Honestly, never tried it before. So yeah, I didn't bring my measuring stick. Don't know how that is. So that's the physical thing. But then the question is, can you perceive? So we're going to do an experiment showing stairs. Can you climb? Yes or no? Yes or no? And there's the results. For short and tall people. Short people, shortish and tall people. 2 categories. Don't ask me how big they were. Roughly 2 categories, different heights, short and tall people. But you can see that there's a cutoff at the 50% level, which is what we use to categorize. At the 50% level, the short people have a critical height around 26, 27 inches, versus the tall people around 32, 33 inches. Makes sense. That's their maximum height that they can step up. There's a centimeters for you. Short, 66, tall, 81. 2 different critical heights. But look, if now you scale the world appropriately, instead of measuring the height of the step in objective physical physicist units, you scale it to the length of the leg, you get the 0.88. In fact, my point here is that in this perception experiment, you get 0.88 in the perception experiment. So people's maximum perceived height is analogous, identical with, their physical ability. So people are very good at seeing the world. And they're not just good at it, they're good at it because they're receiving information in body scale terms. Body scale. What about preferred height? You don't want to do this all day, right? But you might want to do this all day in a gym. So what's the preferred height? Well, we're going to do a test now with oxygen and so on, and show that the energy is minimum for short and tall people at a certain riser height. Shorter for short people, larger for tall people. 2 different riser heights with minimum energy. And you see, notice also at small and big riser heights, energy goes up. So there's an optimal, there's a comfort mode. But if you scale it, you get an ROL of 0.26. About a quarter of your leg length is your preferred height. Okay, so that's the preferred. Now, the perceptual experiment is, can you perceive it? Can you perceive that this is going to be comfortable to walk up? Here's the experimental results. Preferred height can be perceived in the same way by all. So here's the raw data, here's the scaling, and so here's the percent chosen. So most people will choose that height for the short and for the tall, and when you scale it, R over L, 0.25. 0.25 is very close to 0.26, but it's less. Perceived preference is very close, to 0.26. But, yeah, okay, that's my point. They're very close. Very close, okay. Very close. In fact, identical for our purposes. So why are monument steps so difficult to walk on? Because they're not the optimal height. They might look pretty, but they're not. It doesn't look pretty. So Gibson called these opportunities for action in the world, his point, which I'll say more about, is what we see in the world are the opportunities for action. He called them the affordances because, look, because this book affords picking up. It also affords balancing on my head for some strange reason, for a bird to land on it if I had such a goal. It affords many things. It affords chucking. So his point was, it was a functionalist perspective, looking at the larger relations. Affordances are the real possibilities for action in the environment. Leads to not naive realism, but what is called now direct realism. There's been other direct realism in philosophy over the years. This is also direct realism. There's a real world, not populated by shapes, colors, mass, but by affordances. That's the scale, that's the ecological scale of analysis, you see. The ecological scale, not the quantum. Quantum's irrelevant for explaining our experiences. It's irrelevant, one would argue, with this perspective. The astronomical level is irrelevant for explaining our everyday experience. The ecological scale is relevant. It's the scale of animals getting around the world. And affordances are perceivable properties. There must be information that allows you to know through perception. All right, so they're not just concepts in the head. Different people with different body states see the same affordances, same mental states. Right? So you can have different, you and I can see the world. That's why you and I can see the same world. That's why we have language. That's why we can have a society, because we share a similar world. And we can see that world and agree upon it. Have debates, conferences, seminars. So the crucial thing is scaling the environment to the body. The affordances are defined reciprocally, they require an environment, a perceiver, they're real. And Gibson emphasized they're both objective and subjective. So there's a subjective aspect to seeing the world, but there's an objective aspect as well to these affordances. They're not created only when I look at them. So if they're real and if information is available, then affordances can be directly perceived, not a construction in the head. Modern cognitive science assumes brains create reality from physical sensations, meaningless sensations. The ecological perspective, no. We've got to look at the whole system. There's another example, I'll go through this real quick. Can you see whether you walk through a door? Again, the same idea, aperture size. At which point do people's shoulders start rotating? Right, so when you scale the aperture size, the shoulder width profiles line up. Small people, their shoulder rotation starts as it gets narrower. Larger people, the rotation starts also as you reduce the aperture. But there's a critical point beyond random oscillation, and that's the same for people, about 1.3. 1.3. Can it be perceived? Can you perceive it? So that's the real experiment. You measure people going through gaps. Oh, they start rotating as they go through the door, right? But then you do the perception experiment, because we're psychologists. And here's the results for small and large people, right? So is it possible? Yes or no? Again, yes or no? Yes or no? So when it's very small, people say yes. When it's big, they say no. Okay? But when you scale it, boom. And now what's the number? 1.15. Different, but in an interesting way. 1.15 is different from 1.3. It's smaller. It says people will make the judgment of no or yes earlier, as they should, to be careful, to be safe. 1.15 of aperture size relative to shoulder width means that people are going to be more conservative. Right? They're going to be more careful. So in the perception experiment, it's as you would expect from evolution, that people are going to say that they're going to rotate their shoulders earlier than they actually do when you test them. When you test them, they say, oh, yeah, I didn't realize you could go through that. But when you ask them to make a judgment, oh, no, can't go through it. It's as you'd expect through evolution. What about other animals? This is not just about humans. There's far more other animal species in the world than humans. If this theory can't explain other animals, then forget it. You know, Descartes, animals don't have souls, so they can't see the world. They're just machines. Descartes' fountains, Fontainebleau, right? Water-powered hydraulic machines. Descartes' day, that's what they had in the fancy gardens. They were machines, and the analogy then was animals are like that, don't have soul. Well, what about animals? If they make the same judgments, animals perceive their environment in the same way as humans. If my argument's right, then animals see the world in the same way. This very, very famous question from a philosopher called Thomas Nagel, what's it like to be a bat? What's it like to be, it's such a weird question. What's it like? Not what is it to be a bat, what's it like to be a bat? Imagine it, what's it like to be a bat? Maybe you sound, but the sound reflects off things. Very interesting structured energy distribution of sound allows them to do amazing things like fly through gaps that size and so on. But what's it like to be a? Well, remember the 1.15 and 1.3 story? Here's frogs, 1.3. So you do experiments with gaps, see whether they jump through them or not, and you get the same critical value when they will go or not go through the gap. So nature seems to be parsed up, divided up in constant ways. This is what ecological psychology is very excited about now, is that these kinds of invariant relationships are showing again and again that we're continuous with the animal species. So this is not just philosophy, it's practical for architectural design. What sort of sizes are you going to do for riser height, seat height, and so on? You do ecological experiments, and they're different, right? Different numbers. So it's useful. So this is J. Gibson. This is this guy who we're talking about, who's come up with the notion of affordances. They're what the environment offers the animal, what it provides either for good or ill. The verb's not found in the dictionary, I made it up. It implies the complementarity of the animal and the environment. So it's not just physical properties of the surface. An affordance of support for a species, however, they have to be measured relative to the animal. They're unique for that animal. They are not just abstract physical properties. So this notion of complementarity is fundamental. The reciprocity of organism and environment is how people in this area talk about. Information is detected. Affordances are perceived. So this is a technical distinction worth contemplating. So people talk all the time about, oh yeah, perceive the information and cues this and cues that, and perceptual theory nonsense. Cues come into the brain and have to be interpreted, and then do you perceive the cue? And all this confusion. If you want to get clear on what's going on, take out of your library here some James Gibson, and you'll read the most clear thinking about this problem that you've ever come across. So his way of thinking about it is that the information is detected. In fact, he talked about the resonating brain. The brain resonates to information. That is, talk about being ahead of your time. That's how brain scientists now are talking about the brain in terms of information, resonance, frequencies, blah, blah, blah. But the analogy is beautiful. It's a physical analogy. It's a physical metaphor of resonance. Information, the brain, the body, the brain resonates to information. That gets the connection. That gets the epistemic contact. Epistemology, study of knowledge, epistemic contact. How do we know the world? How do you make contact with the world? This is the whole problem of the mind-body problem. How do we know there's a world out there if all we have are sensations at our sensory surfaces? That's the conundrum. Well, Gibson, that's a load of rubbish. It's completely ill-conceived because your argument for illusion is based upon very simplistic experiments where you've got people in chin bouts and they're not allowed to move their head or body or even their eyes, and they get some stupid image, and oh yeah, that looks like a duck rabbit or whatever. His point was that's totally impoverished information. Put the animal in the normal situation, put the human in the normal situation where there's more information, then they have veridical, truthful perception. And what are perceived are not physical, technical terms like lines, lengths, colors, frequencies, whatever. Affordances, inherently meaningful. Here's the phenomenology coming in from William James, who was like his great-grandfather in terms of supervisors. Here's the phenomenology coming in. Affordances, inherently meaningful aspects of the world of what is perceived. Motion is crucial. If you look at this display I'm going to show you, he comes up with these amazing experiments on the deletion and accretion of optical structure. You do not need two eyes to see depth. These are experiments on occlusion. The occluding age was, this is a phenomenological demonstration. You experience not only relative position, but a certain degree of depth as well, almost as if you're looking through a stereogram. Look at that. It's a bit flickery with the projector, but you get an enhanced 3D effect even. You know which one's closer. 3-month-old children, experiments on 3-month-old children will look at that. 6-month-olds will reach out to try and grab it. They'll try and grab the one that seems in front. Look at this. Which one looks more in depth? That one going vertically, or this one going horizontally? I think the one going horizontally does. I don't know about you. Possibly something to do with normal situations that we encounter. Typically things go like that. They don't go like that. What about this? Wow. Did your brain invent a representation of what was behind there? Gibson says, rubbish. You see, there's information in the occluding age phenomenon, information which is still being studied at the right level of mathematical description or whatever. The information specifies that there's an object behind the surface. You're not constructing a memory. I haven't said this before. Traditional cognitive science, memory-based perception. Everything's based on memory. Memory is to interpret the meaningless sensations. Gibson, rubbish, he would say. We do not need stimulation to perceive existence. The occluding age specifies what exists. You look at me right now, oh my God, I've lost bottom half of my body. Oh, you're not worried, are you? You see what exists. Now, it takes a few years to get your head around this way of thinking. I don't know if any of you have been able to do that yet. It took me a while. This occluding age took me over a decade to realize how profound this is. What about this? Babies love that. You show that to 6-month-olds and they start giggling. This is extremely interesting because it seems to violate something to do with normal situations. Surprise, our attention system gets really activated. So, there's somebody from Screen and Media Studies here. You look at this. Again, this is occlusion phenomenon. You do not need a line to see a line. You do not need edges to see edges. You just need the right relations, the right information. So this is dynamic information. This is from the Gibsonian perspective. This is called point light display research. And yeah, you should look into that. So, we do not need a line to see a line. Information for a line is not a line. Information for a thing is not a thing. We do not need continuous stimulation to see if it exists. Relative motion is sufficient to experience depth. We don't have a 3D representation or picture in the head. Oh, it's 3-dimensional. No, we experience depth. My theory, which is mine, my theory about depth is that you don't have a 3D representation. It's that you perceive the affordances and the possibilities for movement. Depth is allowing you to see what's possible in the world. It's all about 3D images. Okay, it's all about higher order relations in the optic array. There you go, dynamic occlusion. So, the importance of self-motion. Motion is crucial for revealing information. Motion is needed to reveal what is invariant. So you look at animals, look at a dog, cocks its head. Look at animals, they move to figure things out. They look like they're trying to understand when the dog cocks its head. Because it's trying to reveal the relevant information. Ancient experiments now in prehistory of psychology in 1963, my God, I think I was born around then, put kittens in the kitten carousel. They had a cylinder with black and white stripes. This one could move its paws and walk. When it moved, this one got dragged around. It went round and round and round these kittens. Right, putting an hour a day for 8 weeks, right, young kittens. All right, the active kitten develops normal depth perception. This guy ends up seeing. This guy does not. So movement is fundamental for revealing, for the relevant information to be brought out. So I'm also going to then give you a quick overview of the visual clip. This is Eleanor Gibson. This is James Gibson's wife. very famous developmental psychologist, also the language of psychology of language, the famous visual cliff. Infants will not walk across the glass. It feels good, feels hard, but they will not walk. And this is young infants. They have not tried this situation. They've not fallen off through trial and error learning or whatever. You know, it's not trial and error. The texture grading, Gibson's texture grading specifies that there's something interesting there. It means something. There's meaning. It affords falling off would be his way of thinking. So this is usual. This is usual. This is very rare. This is the baby floating in midair on the glass. They rarely see this. But even young, newborn goats will not go. Mice will not go. So this is not learning. There's information available, and animals have evolved to detect it. It's Eleanor Gibson in the American Nobel Prize in 1992 from Bush. Okay, the American Medal for Science. She died about 10 years ago. So, driving, motion, optic flow. This is Gibson, 1930. It's starting to think about the field of vision for driving. Hardly know where to stop the car. How can I see the future? This car is going to go through the intersection, so I'll have to stop. Seeing the future. So the ecological perspective emphasizes events. The information is at the level of events. This is Einstein. This is 100-year-old. Everybody should know about this. There's no such thing as the present. There's space-time. Right? So this is seeing the future. I can see that I'm going to hit that wall in, and I'll count down, 5, 4, 3, 2, 1, 0. Something like that. If you're driving a car, you can see the time to contact through the optical velocity. Lots of experiments on that. We've done some ourselves. So this is Gibson 1950, motion parallax. Every textbook now talks about that. Gibson landing an aeroplane, optic flow. Expanding optical patterns specify a direction of heading. So you can see where you're going because of the optical expansion. Optic flow. Like Star Trek, flying through space, stars. The direction of heading is in the information. So again, it's not in your head. The structure of the information supports your experience. So we've done experiments on this in our fancy visualization lab in Australia 10 years ago, looking at dots. And this is the moving room experiment here. We're replicating these are illusory situations where you put people in a room on rollers. And you see how their balance is influenced not by their vestibular system, but by optics. It's as if the optics is causally pushing you and your body. And these are famous experiments now by David Lee. I have a video of it we can watch, but basically, if that room goes forward, it looks as if I'm going backwards, right? If that room is moved forwards like that, it looks as if maybe I fell backwards. So my body automatically compensates by doing that, and then you fall over. And this happens with young children. I can show you the video at the end with toddlers who have learned to stand 8 months, 6 months, and I just fall over. It's like pushing them. So vision is even more important for your balance than the ear. Yeah, I should wrap up quickly now, but an affordance is neither an objective property nor a subjective property. It points both ways, to the environment and to the observer. Cuts across the dichotomy of subjective-object, helps us understand its inadequacy. What does this mean for strong artificial intelligence? We are just computers. That's the theory of computer functionalism. We are just computer programs implemented on different hardwares. Well, this is an amazing robot, but it doesn't have conscious states. This is an amazing robot. You can kick that thing and it recovers. It costs millions and millions of dollars. They're being paid by the military to develop bombing robots. I know the people that designed this at MIT. So look, this is what you get taught. This is what everybody assumes, that cues come into the eye, cause some sort of response of perception. This is indirect perception. This is indirect perception. What I'm trying to present to you is that your perception is specific to information. Information is specific to an environmental property, the affordances. And it's not causal. The relation is not causality here. It's specific to it. It's like pointing. Information points to it. If the information is optic flow expansion, it necessarily means I'm moving forward, or the wall is moving away, moving room. That's direct perception. Direct realism, ecological approach. Perception, action, cycle. Perception is specific information. Information constrains my action. As I move, it reveals new information. That information constrains perception. So we call that perception, action, cycle. All under something still quite mysterious called attention and intention. Change blindness is a lovely demonstration video I can show you where you don't notice changes. And this is what happens when people are on mobile phones now. They talk about visual, manual, and cognitive distractions. And the cognitive distractions, the worst sort, as you will have heard of. And we've done research on mobile phones showing that with a hands-free mobile phone, your initiation of braking is delayed by a quarter of a second, 0.2 seconds, or car length. So quite serious issues with attention. So I'm just bringing in some of our research on attention. This is the second last slide. I want to bring back this big, deep concept of the subjectivity, the experience. You open your eyes, you see red. Philosophers, go to their graves and I'll explain how do you see red. Maybe you see green, but you just say, call it red, inverted spectrum problem, blah, blah. Well, what is seeing? Okay, I'll take you through this slowly. The hard problem of feeling. Okay, so there's an evolutionary biologist called Gunther Wachterhauser. He's German. And he studies the origins of life. He studies the co-evolution of photosynthesis and vision. Photosynthesizing organisms such as blue-green algae existed 2,000 million years ago. Not 2 billion years ago, right? They're called they're actually bacteria. And the blue-green algae or cyanobacteria are prokaryotes, meaning that they've got no nucleus. They're phototropes. Phototropes. They seek the light. They're photosynthesizing. So they will move up gradients of light. They will move up an ocean to where the light is at the top. Light is their food. This is the origins of vision. This is 2 billion years ago. Starting to sound like Carl Sagan. Billions and billions of years ago this happened. Some of these bacteria were heterotropes, meaning that they engulfed and ate some of the other bacteria. They ate them. But they did not digest their prey. They preserved them. This has become known, well demonstrated, as the endosymbiotic theory of where mitochondria come from and where various internal parts of cells come from. The likes of Lynn Margulis, even James Lovelock of the Gaia hypothesis has looked at this, but mainly Margulis from Harvard. And so they didn't digest them, but used these internal photosynthesizers, used them to detect light, because light is where more of those bacteria will exist. So they used the internal guys that they ate to find new resources of more bacteria. So here's the question, is the light a cue, as in Q theory, which needs interpreted by the brain? Well, they don't have brains, but does it need interpreted? Does the meaning come top down? No. The light directly specifies food. We all we are bacteria. We have this illusion that we are some sophisticated sort of thing that has images of the world in our head, and we're so brilliant. We are just a big mass of bacteria floating along the floor here. Highly coordinated, full of synchronizations and synchronicities. I'm giving another talk on synchronization of the limbs. I did a PhD on it. I didn't do a PhD on it. This is just for fun. But coordination, the synchrony of organisms with the environment is bloody profound. And people appreciate that. This is where vision comes. This is where the photodetectors in your retina come from. This is the story. So these internal organelles indicate or resonate where light is. The light is where more bacteria will be to eat. So there's a very direct connection here between what the light is. Cells then develop chloroplasts, photosynthesizing parts, a nucleus. Nucleated bacteria are not bacteria anymore, they're eukaryotes. So you've got prokaryotes and eukaryotes. So perception is the meaningful process of direct awareness of resources. It is the meaningful process of direct awareness of resources, i.e. about food. It's It's all about food. When you look at a painting, you're just eating. Subjective feeling then, well, this is my best shot at what subjective feeling is. It's what this dynamical complex system is. If that sounds tautological, it's not. Subjective feeling is what the dynamical complex system is. It's just what it is. Starting to sound religious. And even Searle is beginning to agree. So for the philosophers, I should play you this. For the philosophers, John Searle he did the Chinese room arguments showing a computer cannot possibly be conscious.
We might want to kind of potentially save it for if there are insufficient numbers of questions.
Yeah, I should not bother with Searle. So I'll leave it there. That's my last slide. Sorry for so long.
All right.
I think this is where people sneak out to go home and pick up their children, which is okay. Please.
And of course, as I just said, you can't have your actions without perceptions. There's a psychologist named Gibson who made a lot out of this. And Gibson, I think he's on the right track. He exaggerates, I guess we all do. But Gibson points out that the standard literature is all about people seeing triangles, or it's as if they're looking through the keyhole of a door, and you have all these perceptual illusions that you can design. But in fact, in real life, you don't just see objects, but you see objects that you can act on. You see potential actions when you see an object. And Gibson's jargon for this was affordances. What Gibson says is that basically what you see is an affordance. So when you look at this thing, it affords one kind of action. When you look at this thing, it affords another kind of action. You can't drink out of this thing, but you can certainly try to keep the rain off with this thing, and so on with all other objects of the kind of useful objects in your vicinity. You see them in terms of the potential actions. You see affordances as opposed to colors and shapes. Well, it's easy to exaggerate that. When I look at a ski slope, I think how I would ski it. But when I look at a rock face, I don't think how I would climb it, because I'm not a climber. When I look at the sky, I don't think, well, how I'd do anything. Maybe if I was a skydiver, I'd think, oh, this would be a great day to do skydiving. So not every perception involves affordances. When I look at trees, I don't think, now, this is how I'd climb that tree, and this how. No, I don't. I'm just not a tree climber. It's not my thing. Not all perception is perception that's oriented to action, but a good deal of it is. Okay, now the way the mind relates to reality, action is fundamental. I don't want to say it's equally fundamental as perception, but it's close. Why am I hesitant to say that they're on a par? Well, you can imagine a beast that had perceptions but no actions. Imagine a beast that lives the life of a tree. It just stands there and observes the passing scene. It has cognition but no volition. But I don't think you can imagine the other side. You can't imagine a beast that could act but couldn't perceive. Because unless you can see what you're doing, or unless you at least have minimal proprioception, unless you have some cognitive capacity for getting at what you're doing, you won't be able to coordinate your actions. And in fact, of course, in real life, the motor nervous system and the sensory nervous system are massively coordinated. So much of your perception is oriented with action in mind. And of course, as I just said, you can't have your actions without perceptions. There's a psychologist named Gibson who made a lot out of this. And Gibson, I think he's on the right track.
What about situations in which people misperceive affordances? Because presumably there are real life situations in which these aren't real life, but the baby crawling across the thing which
we're not perfect.
Perceived a cliff, but there wasn't a cliff actually there was.
Some of the, right, I mean, sure, these things are part of life for all animals. A bird flies into a glass door. arguably there was not information specifying the glass. There was not enough reflectance of it. It's perfectly, there's no reflective light from it. So traditional way of thinking about this is propositions the head that you made a mistake, you made a perceptual error. There was some mismatch between what you expected and what was there. But Gibson's whole program is to say, well, if there's a sufficient information, if there's sufficient structured energy distribution, light, sound, muscular stress strain patterns in the muscles, for haptic, for touch perception. People now talk about haptics, right? Haptics this, haptics. Haptics was invented, this concept from Gibson 66, a chapter on haptics in it. This guy's a genius. So now everybody talks about haptic controllers for their Wi-Fi and PC, their Y device. Touch information is a structured field. If there's enough information, you will get the experience to be expected that the information specifies. So a lot of errors, so-called errors, problems, mistakes, accidents are insufficient information or inattention. If you don't attend to the information, yeah, you won't have the appropriate perception.
But there's nothing going on like, I mean, one would naturally think you have a picture or something of the way the world is in your world. Maybe not naturally, either way, but you have a picture in your head of what the affordances are, and in those situations it's wrong, it's not how the world actually is, whereas in the cases where it works, guides our behaviour properly, then it's true, but you can't say anything like that, I suppose, because you don't think that there is a kind of internal representation.
Yeah, see this Gibsonian perspective, as you can listen to Searle saying, Searle, last year, all his lectures are online from Stanford. I've been listening to them, blooming all, 25 of them. And at lecture 17, he finally says, there's this guy Gibson, and he seems to be on the right track, but he seems to exaggerate a bit, he says. This is amazing. I emailed all my colleagues this saying, my God, Searle has finally admitted it. That they don't want to admit this stuff. They don't want to admit that embodiment and active cognition, all these fancy words now people have been using for 15 years. This is the ecological perspective that's been around since 1966. And we have been struggling to say, no, it's a better research program to carefully look at the visual information or the optical information rather than assume it's impoverished, therefore you must have mental structures and memory. And then we have debates with our colleagues in memory research, and that's all very interesting as well. We do have memories. We do have cognitive states that have to do with our past experience. But the bias from the argument from illusion that everybody just said, well, it must be wrong, so it must be all memory-based perception. And Gibson said, well, that's a bit exaggerated, steady on. Let's do more careful experiments on the informational support. So, although you're saying, well, maybe there's something ahead. Yeah, but what? The more carefully you look at the event-oriented notion of information, not just the moment. You can't define the moment. The past doesn't exist, they say. The past doesn't exist, and the future doesn't exist, so how can the present exist, right? Any 10-year-old would be able to give you that argument. The present can't exist, given these things don't exist. Well, that's box. At least according to Einstein and every other experimental physicist since then has reevaluated our notion, our technical notion of the world. You've got to think in terms of events. So this is an event. Catching is an event. It's not moment being integrated in a big blooming representation in my computer of the brain. No. There is now information that must be defined at the event level. And that's what we do. That's what my colleagues do, is look at new ways of doing. There's a whole area called dynamical systems analysis, which you've heard of, maybe chaos theory and attractors and all this. Right? I mean, it's pendulum dynamics. This thing comes to a stable point. And if you draw the phase plane analysis where it looks like a spiral, position against velocity, they equally get smaller and smaller and smaller. It's a spiral. So you can start using a new technical mathematics, it goes back 100 years, to start describing events and the stable states within the space of events and so on when you're looking at some of these activities. But we're very simple. I mean, my PhD was looking at how people do this. actually decided to do this versus this, left versus right hand. But we just get bowled over with the sophistication of everyday life. We forget that bacteria are worth studying. Does that answer your question?
So when you look at examples like going through the door or the visual cliff, then we're looking at cases where it's something that is, well, crudely innate, you know, but certainly the story will tell us how we learn to deal with parts of the world in ways that we didn't used to, and so hence the post-training affordances are different from the pre-training affordances, it would seem, and so, but yet we didn't, and I'm sure there's a story to tell, but I don't think you really sort of made that distinction.
Learning and all that.
Yeah, yes, I mean...
No, I mean, development psychologist Eleanor Gibson started off as visual cliff, of course, but there's a whole story. She called it perceptual learning, the theory of perceptual learning. The notion is that like wine tasting, you become more and more refined in your ability to make distinctions. But it's not in the head only. I mean, there's real stuff in the wine. There's real stuff in using the computer that I have to learn how to make distinctions in using a computer when I learn to use a computer. So perceptual learning is not, they talk about, it's not the embellishment of concepts, it's not embellishment, it's not the enrichment, it's refining, it's the refinement of attunement. They talk about perceptual attunement to the informational structure. Again, the emphasis on pre-existing potential affordances. So this book obviously affords picking up any 10-year-old, any 2-year-old can see that. But it also affords fancy stuff like reading. And clearly I learned to do that and so forth. And I learned to be able to perceive that affords opening for reading. And so the theory would try then to not see it as one of creating internal structure primarily, but one of refining external structure. This is externalist thrust that's somewhat compatible maybe with some contemporary philosophy of mind, external content, externalism. I feel exactly for what you're getting at and sympathize with it. I mean, it goes against the intuitions of every cognitive psychologist and every man in the street out there. But I'm not denying the existence of structure in the head. I'm just not sure what the structure in the head is doing, and neither really are the experts. But it's a good question, of course, and it is a question that is addressed.
And I mean, and I'm not sort of challenging anything there. I mean,
sure.
I'm just saying, how should the patter go? You know, so you could sort of say, well, now let's, I mean, start with the case of what all of a species will accommodate in the world in such a way that you could describe as affordances, and then you just have to modify the story and say, and now let's look at the case where the person has learned to deal with the world in rather a new way. I mean, maybe under specific training, or maybe just through lots of experiences. And now we will describe the affordances differently. And I mean, I'm not saying there's a problem there, but I'm just sort of saying that the
affordances can change. I mean, through learning and training, whatever your conceptual example of learning and training, the affordances can certainly change. The affordances are acted upon. I mean, how do you know the affordances have changed? Because the animal or the child, individual, acts differently. They approach the situation differently. They do something else. Instead of going there and picking up the hammer and throwing through a window, the trainee picks up the hammer and actually makes something with it, whereas they first just said, oh. So it affords different things through training, or however you want to look at it.
Can I come in on that one?
Yes.
Are you saying the affordances have changed, or the person has become aware of affordances that were already there?
Aware of affordances that were already there. Yeah. So the philosophical the thrust here is that there's a potentiality. It's kind of Aristotelian. There's potential affordances in something. They're real. The ontology here, what exists? The ontology. You look up an article by famous ecological psychologist called An Ontology of Affordances by Mike Turvey.
And the book's going to be a good one for this, right? Because it has an affordance to be read, which is not available to a free literate society.
Right.
But it's got a latent affordance if you kind of give this book to someone who's a member of a pre-literate society. Right? The affordance is still there to be read. It's just not a meaningful.
Absolutely.
So that's kind of what's. Is
Yeah,
that what you're
because
It really
it
can be
sounded
read.
like you were saying that the affordance has changed rather than
Well, no,
do you become
he was
aware?
saying the affordance has changed. I was trying to say, no, you're just perceiving.
Oh, okay.
Different-
No, I was
different-
just offering
different-
you a suggestion, but
So I was surprised you with that.
Well, we somewhat agree. Similar, different affordances, different aspects of the potential affordance. Yeah. No, I agree. It's a slippery slope.
Earlier on, when you were talking about what affordances were, you seemed to say they weren't kind of just states of the world, they were states of the world relative to the person for whom they were affordances. And in that
Right.
case, then the affordances do change if the person changes.
Right, okay, so the old example is a little hole in the skirting board. It's a mouse house, so a mouse, it affords living in for a mouse, but not for an elephant, or not for me. So what is it? So the physicist comes along and says, well, it's a hole by yay dimensions and blah, but not relevant. It's not body scale. It's not a relevant description of the ecological scale of life, of living things, ecological scale. So with the ecological scale, it affords living for this mouse, and it affords for me, I don't know, hiding a pencil. So that thing, what is that thing? Well, that thing's an affordance for me, it's an affordance for it, for the mouse. And they're qualitatively different affordances, yeah. Because it's subjective in one sense, but it's subjective at the same time. This is a big thing. It's not because we're dumb psychologists. This is a 500-year-old problem, mind-body problem, subjectivity, objectivity, reductionism to objective parts. Doesn't work. Works for water, doesn't work for first-person consciousness. Searle comes along and says, well, it's just fancy elements, property, people accuse him of property dualism. He denies that. But he basically thinks consciousness is fancy property of matter when matter is sufficiently organized, etc. And I say, well, that doesn't explain nothing. A lot of other people, including Jerry Fodor, disagree with him. Fodor rightly points out, well, seeing that the water is drinkable has got more to do, surely, with my relation to the environment, Fodor would say, and I would agree, than it has to do with some fancy aspects of neurons in my head that have consciousness, which gives subjective first-person consciousness. So I'm saying, look, there's this whole framework called ecological perspective that takes seriously, from an empirical experimental perspective as well as philosophical perspective, the relation with the environment and trying to get the right descriptors of the environment. Yes, he came up with this neologism of affordance. Things afford actions, it affords living in. Don't ask me, does art afford anything? I think it does, but that's another story. Yeah. No, these are exactly the right questions to ask.
So, following that then, how about if we immerse ourselves in a virtual world? Right? There are, just to keep on using terminology, affordances which are apparent for our avatars, which we take to be affordances, right? And so we conceive them in the same way. It is the case that our avatar can step up this high, but not any further, and so on and so forth.
And we can see that the avatar.
And we can perceive the
I can see
the
your affordances.
affordances that the avatar has, right?
By the way, hold on. I can see the affordances for you. I mean, this is very interesting. I can see that you can step on that chair, but I can see that my wife cannot because she's bored. So actually, I mean, there's a whole social psychology level here. So we can actually see. This is very interesting for other minds. Philosophical problem of other minds. How do I know you got a mind? Blah blah blah. Well, I can also. There's information that also specifies the world for you. So now let's go to your virtual world. Well, thank you very much. I didn't pay you any money to say that. My specific interest is meta affordances. My website's called Meta Affordance, a word I made up. So affordances about affordances, a mobile phone, a virtual reality mobile phone, augmented reality. The camera now superimposes words upon the restaurant that you're pointing it at, telling you what kind of cuisine is in that restaurant. It's like virtual reality, but it's cheaper. It's augmented reality instead of a full-on head display. And I think, it's kind of related, I think that that is now a way of amplifying the information about the affordance of the restaurant. There's now information being made available. It's like a book, only now it's a magic book. In fact, some people in Canterbury call these augmented reality devices. They have a thing called the magic book. You open the book and look through special goggles and things pop out of the book. They call it the magic book. So it's this technology amplified. Your example of avatars, what is your question? Do the avatars have affordances? Or?
It's more about how the affordances that exist in the virtual world connect to the ones we have, and how our perception of affordances is mediated through the
built environment?
The thing we're embodying when we're within the world. Right.
The thing we're embodying, but the avatar, our avatar. Yeah. Our virtual me, I see. So yeah. An avatar, okay, I forgot what an avatar is, so you actually have a virtual me. I'm controlling a virtual me.
Yeah. I could recommend a film for you.
So what's happening there seems to be that we then have...
I thought you were just watching, no, you can watch avatars. No, you can just watch avatars, but you're talking about your avatar, that's different.
Yeah, okay, so the avatar is the thing which is a representation of you in the world, right? So if we're dualists, our body is our mind's avatar, right? If we're dualists in the sense that you've been relying this whole time, our body is our mind's avatar.
Yeah,
right.
Sense, yeah.
So in the same sense, when we're in a virtual world, like the character on the screen is our body and mind's avatar, right? Yeah. And what's happening there seems to be that there are affordances which are going to be there for us insofar as we take ourselves to be the avatar. And there are also going to be affordances for the avatar insofar as it has particular characteristics which differ from the characteristics we have.
Okay, I see what you're doing. This is like a dream. It's like a dream because in a dream, you don't have infinite resolution of information. What makes this real and not hallucination for all you philosophers thinking, maybe it's a hallucination, maybe it's a simulation in the Matrix, blah, blah, blah. What? Yeah, it's a very good movie, it's a very confusing movie called The Matrix, yeah.
I was thinking about Inception. But sure.
Oh, Inception is also very good, yeah. But what the difference is between all of these simulation thought experiments and reality is, in reality, I can continually focus and magnify the information, and that's what makes life different as well. That's what makes real eyes different from computer robots' eyes, because of infinite connection, infinite synchronicity at all levels. Now, in a dream, you cannot, maybe even in a lucid dream, to some extent, you can explore your world, but you don't have infinite resolution. And a computer model, you don't have infinite.
And I'm going to suggest that the virtual worlds are far more like this world than they are like dreams, in that sense.
They are more like it, yes. Maybe, yes, maybe. No. But you don't have infinite, you don't have an ability to focus and magnify through perceptual learning and learn more about stuff.
Sure you do.
Well, no, it stops. It depends on the programmer. It stops at a certain level. You cannot see the object and then turn it around. Won't even let you turn it around. Won't let you explore what it's made of.
Oh, but I mean, there are limits in this world as well, right? So it's not that you're unlimited.
Not really.
Here, right? So you can't see what's kind of on the inside of those pages, right? You know, you can see both sides of the page, but you can't see the middle of it, right? There's a
But my mate, the physicist could see what's in the middle.
Yeah, and my mate, the computer programmer, could see. You know,
that's cheating. That's called cheating.
And how is physics not cheating?
No, my point is the distinction is something to do with the boundary conditions of these two examples of the thought experiment world, the virtual world, versus
Okay, I
real.
didn't mean it as a thought experiment. I mean
Okay.
it as in go into a virtual world, one of the ones which currently exists.
Yeah, but they're crap. They're crappy. My virtual reality lab played with this, fondled this idea for some years, and,
I mean,
and
there
got
are
rejected by
There
it.
are good reasons to avoid virtual reality labs, right? Because you don't need virtual reality, you just need immersion. And immersion doesn't
Well,
require
very
any-
hard
Well,
to achieve.
Immersion's really easy to achieve,
Well,
right? I mean, you
yeah,
get immersion.
just go to the
in-
cinema. Go to the cinema, you get it every night. Yeah.
Yeah, and
Some
I mean,
extent.
you get immersion without any of the things we take to be characteristic, right? You get immersion in, say, the wireframe tank simulators that the
Yeah.
army uses, right? That's sufficiently immersive. to
And
do
what's
it.
immersive about it is this
So-
coupling between movement and
Yeah.
consequent
Right,
visual
so-
information.
Immersion
Sure,
is-
sure, but nobody in there. Okay, so this is so simulation is not the same as replication. There's a category difference between simulation. This is simulation. Robots are simulations. They don't have consciousness. They're not replication. You can simulate everything about my brain, even how the neurons work. Doesn't mean it will have awareness, consciousness, etc. It's not replication. All of these things you're talking about are simulations. They're good. They're interesting and also enjoyable and very close in some ways. The feeling of immersion for people if you haven't tried it, it's remarkable. You put on a headset that changes the visual stimulation as you move your head. So it's different from a cinema. The cinema, the scene changes, but you're not changing. You're not moving. It gets better when you go to Disneyland and the chairs move at the same time. I call it 4D. It's an improvement, but it's still a bit hokey.
I mean, I was just thinking you only need a laptop for immersion, right? You don't need anything to put on your head, right? You need a sufficiently well-realized world that you can act as though you're in it, right?
So what's your point then that then this our reality might be a simulation? So what?
No, my point is I'm just wondering how affordances work in this context, right? And
I think your avatar. I think your simulated. My simulated me walking around in the shoot 'em up game or something is certainly seeing what seem to be affordances, as you've said. But are they affordances? I mean, they're simulated affordances. You can't draw a distinction between reality and everything else.
Yeah, there's a follow-up question.
I don't want computers to ever be thought of as
Yeah.
being aware or conscious. I think in principle they cannot be, because they don't have infinite synchronization at every scale of their being, whereas we do. You look at everything down to the blue-green algae origins of the opsin and the proteins in our photoreceptors at the back of the eye, and where they evolved from millions and billions of years ago. There's something going on there, something so interesting at that level of a complex system that artifacts don't have unless they somehow evolve, and these science fiction notions. I think that's my
There's lots of science fiction which is now fact, right? So you don't want to accidentally dismiss something. Realize it happened last week.
This is a big one this is a big ask that you're making. You're substituting your reality with some technology ideas.
Yeah.
So we're not just a telephone exchange after all. Because that's what they thought our brain was 50 years ago, 70 years ago. Now it's a von Neumann Turing machine.
Yeah.
Or virtual reality simulation, which is anathema to realists.
I've got a low-tech sort of parallel question, really. So, suppose I hire a front-end loader.
Right.
Then, well, prior to hiring it, there were big boulders that didn't offer me the affordance of picking up. Once I've got the front-end loader, I can pick it up. I mean, it's very straightforward, really.
Right.
But I just wonder.
Sure.
How,
So it now affords picking up. Look at this crazy animal. Yes. So the affordance of the boulder has changed because of the extension to your effectivities. The experts in our area call it. You've got affordances, and then one of my co-supervisors in my graduate life, Bob Shaw, said, "Well, we've got affordances, Jimmy. You've got to have the complement, the dual." Not dualism, but the complement, the dual, mathematical dual, of an effectivity. So I have this gripper, But if I had a front-end loader, I'd be able to, I'd have a different effectivity to effect different actions. So yeah, that way I think it gets a lot of currency in today's perspective.
Yeah. I mean, but it comes back to sort of whether the affordances were always there, you know.
Look at that, look. Whether the affordance was always there.
Yes,
Yes.
I mean,
Yes.
go back 300 years ago. I mean, was the affordance there in that boulder that it could be picked up with a front-end loader? I mean, you could say that if you want, but you've got a sort of
This
a little bit of ontological overkill.
Yeah, philosophers. Ed Reed is our society's main philosopher on this stuff. And Ed Reed's argument on that is, as long as there's one member of a species, then that affordance exists. So if there were no JCBs in existence, if there were no backloaders in existence, do you have JCBs in this building? If there were no backloaders, front loaders, or diggers, whatever they're called, in existence, like 500 years ago, then that boulder does not afford. Yeah, I mean, this is true philosophical blue sky.
Potential affordances.
But that was his argument.
Yeah. Now we have potential affordances, right? Such as.
But only potential, given that at least one member of a species exists that could actualize the
Yeah,
affordance.
but so the boulder has an affordance in potential, given that it might be that in the future a front-end loader exists. Right?
So it's a super
potentiality.
potentiality.
It's a potentiality which 500 years ago was going to be, equivalently
Where do you-
crazy to virtual worlds. Right?
Oh, do like this. Where do you draw the line?
But I think
It's your problem.
the argument is what's with this line drawing obsession, right?
What's with that?
Look at all of these other lines which people have drawn, which the passage of time has shown that we should just throw those lines away, right?
What do you
The boulder has no affordance of being moved because look how massive it is. Line gets thrown away when the front-end loader happens, right? And similarly with all the other lines about potential affordances, right? It's not clear that you can stop the potential affordances, right? There's now potential for any and all things which we can conceive of as being
that's
affordances
why
to
it's,
be.
that's why it's not an acceptable
And-
argument.
Well,
Because everything then becomes an affordance.
yeah. Isn't this a problem?
Well, if you're going to take that ridiculous perspective, but
Isn't that the boulder perspective?
well, that's why I'm saying you can't do that.
But you can do it for the
It's
boulder.
mutually defined. Look, so it's a mutually defined concept. So it's both objective and subjective in this way of thinking. So if you don't have the subjectivity aspect in existence, then that affordance cannot be defined. But once the subjectivity comes into existence, then the objectivity of external properties come into existence.
So the potential doesn't happen until you have the thing which could conceivably provide the affordance.
Yeah. There's probably quantum mechanics observer story to be told here about the influence of the observer on reality. But yeah, that's a level, for another day.
Yeah. And
But no,
speaking about
I think that's the answer.
yeah. Speaking about the days, I think we should probably about wrap it up.
Absolutely.
So, thank you very much.